The next thing we want to do is we want to talk about solving linear inequalities. This comes from section 2.7 of the textbook. In order to solve linear equalities, you need to understand how to solve linear equations, know how to graph inequalities on the number line, and understand how to write solutions in interval notation. Upon completing this presentation, you will be able to solve linear inequalities by hand and check solutions to linear inequalities. So our procedure in order to solve linear inequalities is the exact same thing as for solving linear equations. Make sure that you carry the inequality sign throughout the problem, meaning do not change it to an equal sign or drop it completely. So remember that our procedure for solving linear equations involved distributing to clear parentheses, simplifying each side by combining like terms, moving terms around by moving all variables to one side and all constants to the other, and then dividing by the coefficient. The one thing that makes solving linear inequalities different from solving linear equations is if you multiply or divide by a negative number, you do want to flip the inequality sign. We'll talk about why this is in a few minutes. Finally, the last thing we want to do is check our solution. We want to pick a number that satisfies the solution set and is not the critical number, and plug it back into the original inequality. If you get a true statement, then your inequality symbol is correct. So real fast, let's talk about why we need to flip the inequality symbol. So let's look at a quick example here. Let's say we want to look at 5 and 10. We know that 5 is less than 10. And so what we want to know is what happens when we do different operations to our statement. If we add a number to both sides, let's say 5 plus 4 and 10 plus 4, is it still a true statement? Well, we get 9 is less than 14. That is true. If we subtract a number from both sides, let's say 5 minus 2 and 10 minus 2, is it still a true statement? Yes. So adding and subtracting is not going to change our inequality sign. So let's talk about multiplying and dividing. What if we multiply by a positive 2? If we multiply by a positive 2, we get 10 is less than 20. That is still a true statement. If we divide, 5 divided by 5, is that less than or equal to 10 divided by 5? We get 1 is less than 2. That is still a true statement. So multiplying and dividing by positive numbers is not going to change our inequality. But what happens if we bring in negatives? What if I multiply 5 times negative 2 and 10 times negative 2? Well, we get negative 10 and negative 20. Is negative 10 less than negative 20? No, it's not. We need to flip our inequality. And basically the reason is because we have flipped the whole thing. So whatever was on the right is now going to be on the left. Whatever was on the left is now going to be on the right. Similarly, if we divide, if I divide 5 by negative 5 and 10 by negative 5, do I get a true statement? We get negative 1 and negative 2. Is negative 1 less than negative 2? No, it is not. So notice that here we also have to flip our inequality for the same reason. We are basically flipping around the 0. And again, whatever was on the left is now on the right. Whatever is on the right is now on the left. So this is the main thing that you need to remember when solving inequalities, is when we multiply or divide by a negative number, we need to flip our inequality symbol. Okay, so let's go ahead and look at some examples that involve solving inequalities. If we look at example A, we have 4x minus 1 is greater than or equal to 3x minus 6. So as I mentioned, in order to solve inequalities, we're going to use the same procedures that we use for equations. We just want to make sure that we keep our inequality sign. So my first step for this problem is I want to get all the variables on one side and all constants on the other. So I'm going to start by subtracting 3x from both sides. When we subtract 3x, we get x minus 1 and negative 6. Now remember that subtracting, we don't have to flip the inequality sign. So we get x minus 1 is greater than or equal to negative 6. With all of our variables on the left, we now want to go ahead and move all constants to the right. So in order to get rid of minus 1, I want to add 1 to both sides. So our final answer is x is greater than or equal to negative 5. From here, we want to go ahead and graph our solution, as well as come up with the interval notation. So to graph the solution, I'm going to have my number line.
Well, I'm back from Albuquerque.
All right, so in order to graph this, we want to start by plotting negative 5. And I'm going to do this the lazy way. I'm just going to put one tick mark on my number line, label it as negative 5, and then go from there. On exams, this is perfectly acceptable. I'm assuming that you already know where negative 5 is on the number line. So from here, we want to go ahead and shade the side indicated by our inequality. We want numbers that are larger than negative 5, or since our variable is on the left, we can follow our arrow and shade to the right. At negative 5, since it is included, we will use a square bracket opening towards the shading. Finally, we want to write our answer in interval notation. So if we go ahead and write our interval notation, our leftmost value is negative 5. Our rightmost value is positive infinity, since we are going to the right. Negative 5 will have a square bracket. Infinity will have a parenthesis. Now, as far as checking your solution, for our check step, I'm going to assume that you solved this correctly and that negative 5 is your critical number. So pick a number that satisfies our final inequality that we came up with. What is a number that is larger than negative 5? There's a lot of them to choose from. I'm going to go with 0. Is 0 greater than negative 5? It is. So if we plug 0 into our original inequality, we get 4 times 0 minus 1. And I want to know, is this greater than 3 times 0 minus 6? Well, 4 times 0 is 0, or it cancels out. We get negative 1. Is greater than or equal to 3 times 0 is 0, or cancels out. We have negative 6. Is a -1 greater than or equal to -6? It is, which means that we should have solved this correctly. And we're done. All right, let's go ahead and look at example B. Example B, to start off with, we want to divide both sides by -3. This is -3 times x. To get rid of multiplying by -3, I want to divide by -3. So here's the thing. I'm going to first off start by writing this as x is less than -7. Now, if we go ahead and check this, pick a number less than -7, let's say -8. If I check -8 in my original inequality, we get -3 times -8. I want to know, is this less than 21? Well, -3 times -8 is positive 24. And is 24 less than 21? No, it's not, which means that we did something wrong. Our problem that we have is that we used the incorrect inequality. Here, since we divided by a negative number, remember that you do have to flip your inequality. So my solution is actually x is greater than -7. If you pick a number greater than -7, again, 0 is perfectly fine. 0 is greater than -7. If we plug it in, we get -3 times 0, and I want to know, is that less than 21? Well, anything times 0 is 0, and is 0 less than 21? Yes, it is. So our inequality should be good here. All right, so now we want to go ahead and graph this on the number line. If we graph this on the number line, again, I'm going to do this the lazy way. I'm just going to put one tick mark, label it as -7. Since our variable is on the left, we want to shade to the right. We want to follow our arrow. Or where would 0 be in reference to -7? It would be to the right of -7, so we want to shade to the right of -7. Since this is a strict inequality, since -7 is not part of our solution set, we want a parenthesis. And so there is the graph for our inequality. Our interval notation, our leftmost value is -7. Our rightmost value is, again, positive infinity. And we want parentheses around both of these, -7 because it's not included, and infinity because infinity is never included. So that takes care of two of our basic problems involving inequalities. Let's go ahead and step it up a little bit and look at some that are just a little bit more challenging. If you notice, these are problems that we looked at in the previous section. The only difference is that we now have an inequality symbol instead of an equal sign. So if we look at example C, again, there's two ways that we can solve this. We want to start by moving variables to one side and constants to another. Now, if you are the type that you always like your variable term to be positive, then you might sit there and say, okay, well, let's subtract 7x from both sides. And if we do that, we get our 7x's cancel. We are left with a 15 on the left. We have that is greater than or equal to 6x plus 51. From there, since our variables are on the right side, I need to move my constants to the left. So if we move 51 to the other side by subtracting it, we get 15 minus 51 is going to be -36 is greater than or equal to 6x. My 51s on the right cancel. From here, we can divide by 6. Since this is a positive 6, we do not need to flip the inequality. So we get negative 6 is greater than or equal to x. Now let's solve this again. And this time we're going to move our variables to the left side. If we do that, we are going to end up with let's write out the problem first. We can move our variables to the left. We get subtract both sides by negative 13x. We get negative 6x plus 15 is greater than or equal to 51. Since my variables are on the left, I need to move my constants to the right. We get negative 6x is greater than or equal to 36, and now I need to divide by negative 6. Now, since we are dividing by negative 6, I do need to flip my inequality. And note that these two answers are the same. On each one of them, I do have my crocodile mouth opening towards negative 6. From here, we want to go ahead and graph this. My graph, I have my negative 6, and which direction do we want to shade? Well, we want numbers that are going to be smaller than negative 6. Remember here that since we have our x on the right side, we cannot follow the arrow. We can only follow the arrow if our variable is on the left. So if you're looking at this one here, just be very careful that you are picking numbers that are going to be smaller than negative 6. That means that we want to shade to the left, and at negative 6, I want a square bracket opening towards the shading, since it is included. Now for our interval notation, my leftmost value, since we are going forever to the left and we are on the negative side of the number line, it will be negative infinity. My rightmost value is negative 6. We use a parenthesis around the negative infinity because you can't equal it. And we use a square bracket for the negative 6. Now, if you want to check this, we want to pick a number that is going to satisfy this inequality. So let's work with negative 7. If we plug negative 7 back into the original equation, we are going to get 7 times negative 7 plus 15. I want to know, is that greater than or equal to 13 times negative 7 plus 51. So 7 times negative 7 is negative 49. We can add 15 to that. 13 times negative 7 is negative 91 plus 51, and if we simplify this, we will get negative 49 plus 15 is negative 34. Negative 91 plus 51 is negative 40. And is negative 34 greater than or equal to negative 40? Yes, it is. All right, so that takes care of example C. So for example D, the first thing that we want to do is we want to go ahead and distribute to clear the parentheses. If we do this, we get 2x minus 6 plus 5x is less than or equal to 8x minus 8. We can combine like terms on the left side. 2x and 5x combine to give us 7x minus 6 is less than or equal to 8x minus 8. Now I'm going to go ahead and move my variables to the left because I just like having them on the left side when I'm dealing with inequalities. So I'm going to subtract 8x from both sides. We get minus 1x minus 6 is less than or equal to negative 8. I can add 6 to both sides to get my x's by themselves. We get negative 1x is less than or equal to negative 2. And finally, divide by negative 1. Since we divided by a negative number, I do want to flip my inequality sign, so this is going to be x is greater than 2. From here, I want to go ahead and graph my inequality. If we graph the inequality, I want to put a tick mark, label it as 2. From there, we want to go ahead and shade the side indicated. Since my variable is on the left, I can follow my arrow. I want the numbers larger than 2. And at 2, I have a square bracket. So this is my graph. My interval notation, my leftmost value of the shading is 2. My rightmost value, since this goes on forever, it's going to be a positive infinity. I want a bracket at 2, and I want a parenthesis around infinity. So now let's check this. Pick a number larger than 2. I'm going to go with 3. If we plug in 3, we get 2 times 3 minus 3 plus 5 times 3. And I want to know, is this less than or equal to 8 times 3 minus 1? Well, 3 minus 3 is 0. So we get 2 times 0 plus 5 times 3 is 15. And I want to know, is this less than or equal to 8 times 3 minus 1 is 2. So 2 times 0, that cancels out or is equal to 0. So on the left, we are left with 15. Is this less than or equal to 8 times 2, which is 16? Yes, it is. And so our solution is, in fact, x is greater than or equal to 2. So that takes care of some of our more complex examples. Hopefully that makes a little bit more sense. And you understand how to solve inequalities. So now inequalities are not something that just come up in math class. You do see these in real-life applications, real-life problems. So we're going to look at a couple examples of an application involving inequalities. So for the first one, this is kind of one that you want in college. We have, to earn an A in the course, you must have a final average of at least 90%. On the first 4 exams, you have grades of 86%, 88%, 92%, and 84%. If the final exam counts as 2 grades, what must you get on the final to earn an A in the course? So one of the things that we know that tells us that this is an inequality problem is we have the words at least. At least implies that we can have a range of values, and so it's not just one. So let's go ahead and look at this and see what we need to do. The first thing that I notice is I see the word average. So in order to complete the problem, we need to know how to calculate an average. So recall that to calculate an average, we want to add up all of the scores or all of the numbers and divide by how many numbers are present. So let's start with that. We have our numbers are 86 plus 88 plus 92 plus 84. Those are the first four exams. The other piece of information we have here is it says the final exam counts as 2 grades, which means that I want to add 2x onto my other grades, and now we want to divide by the total number of scores. We have 4 tests, but we also have the final counts as 2. So this is technically 6. So this is how we're going to calculate the average. Now it says that I want to have a final average, which is what this is, of at least 90%. So I know this is related to 90 in some way. The words at least translates into greater than or equal to a 90. So this is our model. The next thing that we want to do is go ahead and solve this. The first thing that I'm going to do is I want to get rid of the fraction. By doing that, or in order to do that, I want to multiply both sides of my inequality by 6. On the left side, they cancel out. And on the right side, we have 90 times 6 is 540. I'm also going to go ahead and add the 4 scores that I know right now. So if we add these, we should get 350. So we get 350 plus 2x is greater than or equal to 540. From here, I want to go ahead and subtract 350 from both sides. That will result in 2x is greater than or equal to 190. From here, we can go ahead and divide by 2. If we divide 2 by both sides, or both sides by 2, we have x and 95. If you think about this in terms of the context of the problem, do we want to flip our inequality sign? Well, the answer would be no. 1, we're not dividing by a negative, but 2, if I flip my inequality sign, then that would say that you can get anything less than a 95 and earn an A in the course. And though that sounds like a good idea, that's not the way it works. That's why we get stressed during finals week, is because we do need to have a grade that's higher. Finally, the last thing that we want to do is interpret our answer. The interpretation, you want to make sure that you do include a phrase that implies that we are talking about an inequality. So for instance, you can say, you must earn a 95 or higher. Another one that you can say is you must get at least a 95. Or you must get a minimum of 95. And of course there are some other phrases that you can use, but these are the most likely ones that you will see. Okay, so that takes care of that problem. One more. If we look at application B says you can spend at most $1,000 to have a picnic catered. The caterer charges a $150 setup fee and $25 per person. How many people can you invite while staying within your budget? So, one of the first things that I see that we're wanting to know is it says you can spend at most $1,000. That is our inequality. Now, to come up with the amount that we're going to spend, it says the caterer charges a $150 setup fee. This is going to be a constant because it doesn't matter how many people you invite, it's just going to be $150. In future math classes, you will refer to this as the initial cost or initial value. So we pay $150, and then it says that we pay $25 per person. When you see that word per whatever, that means that you want to multiply it by something. So this is going to be 25x. So this is the amount of money that we're paying, and we know that this is at most $1,000, meaning that I can spend less than or equal to $1,000. Now that we have our model, we can go ahead and solve. We want to start by subtracting 150 from both sides. On the left side, our 150s will cancel, leaving us with 25x. On the right side, if we subtract 1,000 minus 150, we are left with 850. From here, we can divide both sides by 25. And if I'm doing the math in my head correctly, I come up with 36. I do recommend that you check that though. Okay, so we've finished our solving, and so now we want to go ahead and interpret. So our interpretation, you can invite at most 36 people. Keep in mind you can invite less. You can also say this, you can invite $36 or less people, 36 or fewer. You can invite a maximum of 36 people. Either one of any of these would be considered correct, as long as it is some form of inequality interpretation. If you say you can invite 36 people, that statement in mathematics means you can invite 36 and that's it. It does not imply that you can invite fewer than 36 people, and it does not imply that you can invite more than 36 people. It's just 36 people. Okay, so there are some application problems. So let's talk about linear equalities in general now that we're done with this. When will we see this again? We will expand the concept of solving linear inequalities when we look at linear inequalities in two variables, assuming that we have time. In future math classes, you will look at inequalities involving all types of algebraic equations. You will see them in quadratic, absolute value, rational, radical, etc. You will also, just as a side note that I forgot to include in the last presentation, interval notation and graphing, you will see these again with these future equations. You will be introduced to a concept known as domain and range, which is another area where you will see interval notation. Once you feel that you understand these problems to the best of your ability, go ahead and try the following problems on your own. Bring your answers to class along with any questions that you might have.